Thank you. Thank you for introduction, and I would like to thanks to the organizer for giving me this chance to give a talk here. It's my great honor and pleasure to come here and give a talk. So today I'll talk about semi-orthogonal decomposition of derived categories Fanos and the Ulrich bundle. So I think this definition of Ulrich bundle is not familiar for everybody. So maybe I will briefly recall what is ACM bundles and Ulrich bundles. So maybe the first, motivation for this Ulrich bundle is by theorem of Ulrich. So he proved that when E is a vector bundle on projective space, then the intermediate cohomology Pn of E shifted by J is 0 for every J and I greater than or equal to n-1. He proved that vector bundle satisfying this condition should be isomorphic to direct sum of line bundles on Pn, K, and K from 1 to rank. And of course it's easy to see that this bundle satisfying this property. So for Pn, the vanishing of this intermediate cohomology is equivalent to this is direct sum of line bundle. So people try to find this kind of bundle for other varieties. So they define so-called arithmetically co-macquarie bundle on Pn. So let X be a smooth projective variety. Then I have fixed a very ample line bundle by fixing this embedding. Then a vector bundle on X. Let me just use vector bundle. Then I call E is ACM if the above condition satisfy. So HI X E shifted by J is 0 for every J and I dimension X-1. And the Ulrich bundle is so when on ACM bundle E is Ulrich if it is satisfies some special condition. It's like this H0 X E shifted by -1 is 0 and H0 X E is nothing but length and degree. If a bundle satisfying this condition, then I call this Ulrich bundle, and this is just the above condition. So H0 of Xe is length of vector bundle times degree of X. So I fix an embedding of X to Pn, and So maybe the simplest example is for example as this Ulrich's theorem says that this direct sum of line bundles on Pn is ACM, and I can consider quadric in some projective space. And then you can prove that direct sum of this is also HM. And maybe I will define later this. The spinor bundle is also HM bundles on this quadric. So these two are very typical example of HM bundles on quadric and the PN. And then why this Ulrich condition is special? So Eisenberg and Schreier proved the following result. Why these kind of bundles are special? Eisenberg and Schreier prove that. So as above. Then they prove that the following conditions are equivalent. So first, E is Ulrich. And second, let me just write it this way. HI E minus J is 0 for every I, and so J from dimension. And third, for all projections, all projections of my X to P. So as I told you, I fix my embedding. So this, whenever I have defined some linear projection, then this push forward of E is isomorphic to O length and degree. And fourth, so X has linear CGG. So like there exists a linear resolution of my ship E. So such that L codimension C. This is codimension to O 0 to E, where Lj is some O P N minus J P. So they prove that these four conditions are equivalent. So let me give you example of Ulrich. So I give two examples of HM, but let me give you two examples of Ulrich bundle. So as condition says, this in this case, this O times length is Ulrich, but O plus O1 as see the definition, this is not Ulrich. And for quadric case, this direct sum of O something like this is not Ulrich. But this spinor bundle is the only Ulrich bundle. This is obvious from definition, but let me give you one more example. This is also easy to see, but it's quite fun to see this one. So I consider some conics in P2. Then let me, of course this, and my claim is that because this is as you know, this is isomorphic to P1. So my embedding is so okay. X and O X1 is nothing but P1 and O P12 because this is conic. So then my claim is that E, which is OP1 minus 1 is Ulrich. Plus 1. Then you can see that this by definition yeah, this is 0, and this is nothing but length. Length is 1 and degree 2. So this is yeah, Ulrich bundle. And the second, yeah, you can check that. Okay, let me just H0 of P1 O minus 1 is H1 is also 0. And the third, I have P2 and the conic and P1. So I take any linear projection of my, I push for this bundle, then pi E is nothing but O2. And the fourth, I can yeah, say this, yeah, I can have a very trivial linear resolution. And as x2, x1, x1. And yeah, this cokernel should live where this determinant vanishes. So this is my E. So this is supported on the conic, and this is indeed O1. So you can see that when X is hypersurface, this having Ulrich bundle is related to that this equation of the variety is written by determinantal equation. In this case, it's determinantal equation. And as I told you, this when X is, for example, Grassmannian 2,4 in P5, then this spinor bundle. So I have a U and Q dual. These are Ulrich. You can check this. And again, these can be written as Papian. You know that. Yeah. Length 1 Ulrich bundle. In this case, this is several copies is possible. Yeah. So, and again, this is written by Papian. So it means that this equation is, again, this is hypersurface. So I have some resolution of this U or Q dual in this way. And this is again related to that. One can see this equations is written by determinantal of some matrix. So so Eisenberg and Schreier asked maybe conjecture or question. So this Eisenberg and Schreier asked that for every smooth projective variety, so projective, they ask that there exists Ulrich on X, and this is still So I reduce. I restrict my attention to smooth projective variety. But that's right. So let me recall what is known for known cases. Maybe I already give you several examples, but let me say. So for curve case, if I take any line bundle such that H0L is H1L is 0 as before, then this is Ulrich. Then L shifted 1 is Ulrich. And as you see that if I consider this Picard G-1 of C, and then the variety having, non-trivial section is divisor in here. So you see that there are lots of Ulrich shapes on there. And for the phasor surface, if I consider surface S, if I consider two lines, L and L prime, and this OL minus L prime shifted 1, you can easily check that this is again Ulrich. And recently, Bobile And yeah, surfaces cases was studied by Bovil and yeah, Casnati. And also, yeah, many people, Aprodo, Farkas, Ortega, and many cases. So, for one-dimensional case is known, surface case there are lots of results. So I will try to discuss this problem for Fano 3-4 today. But why Fano 3-4, the Ulrich boundary is an interesting object, is that you see this among these four equivalent conditions, the second condition says that, okay, sorry, let me just, yeah, let X be a Fano maybe 3-4 of index I. Then by Kodaira vanishing theorem, I have always some kind of exceptional sequence. I minus 1 is always become exceptional collection. Then again there is a semi-orthogonal decomposition corresponding to I minus 1. And the second condition implies that my Ulrich bundle always live in here. So I can reduce. So what I mean is that I want to, there are known cases, and I want to study Ulrich bundle on Fano 3-4. But in this case, this condition implies that whenever because every Fano 3-4 there's a non-trivial semi-orthogonal decomposition, I study this Ulrich bundle using this semi-orthogonal decomposition. But that's that's basic idea. Indeed, these approaches was used by Sasha Chnesov to study instanton bundles. His study of instanton bundles on Fano 3-4, and also Lahos, Macri, and Stellari use this approach to study cubic hypersurface case, to study Ulrich bundles on them. Is there any question? Yeah. So, So, in this case, what I mean is that, in PN case, this we have a Berlinson sequence, and this semi-orthogonal decomposition implies that O is unique Ulrich bundle on PN, because every element orthogonal to only, what I mean is that there are finite cases that bundle has only finite ACM. What I mean is that this one and quadric, and only 3 or 4 cases that we know there are finitely many ACM bundle. So Ulrich bundle is much more restricted. What I mean is that variety admit finitely many type of ACM, even ACM bundle is, there are finite cases, but I will show you some example where we can see moduli of Ulrich bundle. And again, let me just anyway finish this one. So this is Kaplanov collection, this case, and the spinor bundle or spinor. So you see that Qn, this S spinor bundle is unique Ulrich bundle because of this condition. Okay, so then I want to discuss Fano 3-4 of index 2 today. So Fano threefold case, as you know, so X is Fano 3,4. As Sasha already discussed, index is always less than or equal to 4. So I is 4, then P3, we know there are Ulrich bundle, and the I equals 3, also quadric, we know. And the I equal 2, we have 5 cases, so degree 5, so it's V5, which is embedded into Grassmannian 2,5. And the D equal 4, and this is the intersection of 2 quadric in P5. And the D equals 3, this is a cubic hypersurface in P4 in some cases. So I will mostly discuss these cases today. And there is a theorem by Bobir who says that in these cases there are rank 2 Ulrich bundles on V4, V5, and let me call it V4 and V4, and they form smooth 5-dimensional moduli space. So Bobir already proved that there are rank 2 Ulrich bundle on these cases, and they are 5-dimensional, already 5-dimensional moduli space, this case. But yeah, so how he proved this result is that he used set correspondence. Let me just mention that he proved this theorem uses set correspondence. So he constructed certain elliptic curves in this elliptic curve of degree d+1 by some deformation argument, and then use status correspondence to prove this one. But what I want to mention is that for rank 2 case, it's might be possible, but from rank 3, the curve inside, what I mean, the status correspondence basically see that codimension 2 subscheme of this Fano variety, and the curve is become really difficult to construct when rank becomes high and high, and there's no result for rank 3 using these cases. And I want to some result. So let me X be intersection of 2 quadric in P5. Then by theorem of Bondar and Orloff, see that this derived category of X has a semi-orthogonal decomposition OX minus 1 and OX, and the derived category of C. So maybe people from Moscow knows this very well, but let me just briefly recall what it is. So C is as you know, we consider pencil generated by these 2 quadric. Then there are 6 points where these quadric degenerate. Then I consider 2-to-1 covering over this curve. Let me find that this 6 point. So this is the curve, and then there are, this can be, indeed I think it's very interesting that this C is a moduli space of a spinor bundle on S, so I can write this X, but it is also classically very well known. So C is a moduli of X, but this is also many cases true, but this X is also, it is well known that this is a moduli space of vector bundles on curve with rank 2 and fixed determinant. So I see degree odd. So if I choose one odd degree line bundle on C and consider this famous moduli space of vector bundles on curve with a fixed degree, fixed determinant psi, then by theorem of Mukai or Narashman, Ramanan or Neustadt, and there are three independent groups proving that this is moduli space of this one. And in this case, this is also universal family. There's again we can consider universal family in this moduli point of view, and this are same. Okay, this also generalized by Anton and Sasha by cases. So you can ask many people here. Anyway, so there's this Semiorthogonal decomposition, and by what I told you last time, previous time, my Ulrich bundle lives inside here. Then, what is my Ulrich condition says? That's home X of E dual 1 pi OX minus 2 shifted by P is 0. Because I already have two vanishing via this and this one. So I have one more vanishing here. And then by this semi-orthogonal decomposition, this is equivalent to say that I consider I consider adjoint functor, and this adjoint functor OX minus 2 shifted by P. And so thanks to again Sasha, this is also computed by Sasha that this is a Raynaud bundle times OC times 2 shifted by minus 2. One can check that there's this so-called Raynaud bundle satisfying this condition. So so I want to construct some Ulrich bundle. I want to study Ulrich bundle on X via this kind of semi-orthogonal decomposition. Then what I have to find is that find a certain object in derived category of C satisfying this vanishing condition. And there's one more condition. This element, this complex in derived category, should go to vector bundle here, right? So there are two conditions I wanted. So this complex should orthogonal to this object, and my complex should go to some vector bundles on here. Okay, so if I found such object, then I can construct this Ulrich bundle on my Fano 3-4. So what shall I do? So I just, please assume that I have certain rank R Ulrich bundle on X. If there exists a rank R Ulrich bundle on X, then I can show that this functor send this element to a vector bundle of rank R and degree 2R. So you can compute that, the cohomology. So if I have this some object satisfying some condition here, then I just send it here, and we can check that all cohomology except 1 degree vanishes. So this is rank R and degree 2 are only found on here. Then I want to, okay, then this become a vector bundle problem. So I consider all vector bundles of this length and this degree on my curve, and then I want to check that this pi s is vector bundle, and this home f with R dual this vanishes. And how can I do that? Just the idea is very simple, because my curve is genus 2 curve. So the moduli, I consider all moduli, all vector bundles of degree. I can also prove that this is a semi-stable vector bundles on rank R degree 2R on here. So I consider moduli space. This is very well-known spaces. So I have a moduli space of vector bundle of rank R and degree 2R on my curve, and it is known that the dimension of this space is nothing but R squared plus 1. So you see that rank 2 case, Bobir already proved that this is a smooth 5-dimensional case, 5-dimensional manifold. So one might guess that this Ulrich bundle form open subvariety in here, right? So what I should do, I check that I compute the dimension of bundles here whose image is not vector bundle and whose image is not doesn't satisfy this condition. And very luckily, I can check that dimension of such f. This is some technical, but I can manage to compute this one is always less than or equal to R plus 1. So it means that there's a Zariski closed subscheme which doesn't satisfy this condition, but I ignore those things. And I consider some generic point here and send it, then this becomes Ulrich bundle of rank R and Ulrich bundle of rank R on X. So this is a basic idea how one can prove this Ulrich bundle on this variety. So let me state theorem. Myself and so my theorem with Yong-Ha Cho, who is in Kias, and Nak Kim, who is in Germany, myself. So we proved that when R is greater than or equal to 2, then my moduli space of rank R Ulrich bundles on X is embedded into this classical moduli space of vector bundles on curve of this degree. So there's no Ulrich line bundle here. You can easily check because this is Picard number 1. But I can prove this one. And moreover, if I consider stable Ulrich bundle, then this stable Ulrich bundle goes to stable vector bundles here. So if I consider stable Ulrich bundle on X, then this goes to stable vector bundle on curve with rank R and degree this one. And you know that this part forms a smooth subvariety in this singular variety. So anyway, this generalized the theorem by Bobir. So he proved this rank 2. Oh, because he more cases. What I mean that I consider only V4 this case, but anyway generalize this result for these cases. And again, we can play a similar game for other varieties. And let me write one more theorem. So V5 case, it is known that, so as I call it V5, then this V5 is embedded into Grassmannian 2,5. So there are rank 3 vector bundle here. And I consider some generic section, then this is zero locus of this one. And by definition, by construction of this V5, we know that there are some trivial sequence. And it is again by theorem of Ulrich. So derived category of V5 is generated. So we have this kind of description. And this, when I see this, again I look at this one, and then this is a strongly exceptional collection. So by Bondal's theorem, we say that this part is nothing but derived category of a Kronecker-Kieber of 3 arrow. So then one can play same game for this one. And let me just say one more result. So result by myself and Kyungdong Park, who is in IBSCGP. So we prove that this moduli space of Ulrich bundle of rank R on V5 is embedded into the King's moduli space of, let me call this Kieber gamma. So then King construct, whenever I Kieber, then King construct the moduli space of representation of this Kieber. So, and okay, let me say it this way. So then I can compute, so using similar idea like that, I can compute that the Kieber representation has dimension R and R here. So I consider R. I can compute it that way. And this vanishing of O2 gives me some kind of stability condition on this moduli space. So I have theta So this is, I have theta semi-stable, this corresponding to my OX minus 2. So I have a theta semi-stable representation, moduli space of theta semi-stable representation of this Kronecker-Kieber. So I can prove that this is embedded, and if I consider stable, then this also becomes stable. And then again, this generalized theorem by Bouville for this case. So this case is open. So, and even more, this is a very concrete description because pardon? Embedding is open. So this variety forms open subvariety in this moduli space. And anyway, indeed this map is much more obvious than this one. Okay, that one is also obvious. But anyway, in this case, this is nothing but this dual rank R. So this is rank 3, and this is rank 2. So if I think co-kernel, then this is rank R Ulrich. So one can also find some explicit description using this moduli space. So that's what I want to say as an application of this Semiorthogonal decomposition of Fano. And indeed, one can, I think, this is indeed almost same game. Whenever I have Fano 3-4, or a higher dimensional Fano variety, and I consider Ulrich bundle, then almost always I can reduce my problem to this subcategory. But these two cases are very lucky cases because the A is very explicitly described these cases. But many cases describing this is very hard. So that's one difficulty to generalize these to other Fano varieties. But I think if A is well known, then this is not difficult. So one can always do this kind of game. And then, okay, I will. So that's application part of Fano Semiorthogonal. Of course, I think here many people knows more application than I. But this is a application what I have in mind. Then shall I? Maybe I can. How many minutes? Okay. So then so maybe, frankly speaking, this is a good time to finish. But if maybe if I have time more, then I will discuss a little more about this so-called Fano visitor problem, which I have one. I don't know. Maybe I don't know which one is better to finish. Yeah. There can be many. How can I say? You mean that why we consider this kind of bundle, right? For me, the personal answer might be this. What I mean is that so this is my personal point of view. So please know. So when I have a curve, then this topological type of maybe as you know this length. So what I mean is that when length and degree are determined, then we know that this topological type of E is determined. So what a curve case, this maybe length 2 and degree odd and even, then we see that this is we have a very good understanding of vector bundles on curve. But when I go to higher dimensional case, then in order to fix this topological type, then I should check this and the C1 and C2, and it's become higher and higher. So what I mean is that for higher dimensional variety case, I think it is very hard to decide which bundle to study. For my point of view, I want to study some vector bundles on higher dimensional variety, but this Ulrich bundle is supposed to believed to exist for every variety, and also this has very nice property as I show. It has some meaning of CGG, and also existence of Ulrich bundle says some kind of cohomological defining equation of X, and also there's one thing I can't understand. Maybe you can explain. There is a so-called Bohr-Sommerfeld theory about these things. So
I can say that. That's supposed to know. You can consider two things, right? You have the polynomial ring and the standard ring. So on one hand, you have Tn, and you can consider all vector sheaves on Tn and all cohomology tables. Okay, so I can save my sheet, I can twist it to any line bundle, and I can compute all cohomology. So you get like an infinite table which sits in between O and N. And on the other hand, you have graded modules over your graded table. And then you can consider just resolutions of your modules, like table resolutions, and each thing gives you another table, which is this Betz-Anders in the resolution. Like in place I have O of minus J taking this number. So it turns out that if you consider these tables, the set of these tables, as proportionality plus the inversion by this unit circuit, it prove anything, but they sort. And you actually get collegial cones. And what Eisenblatt proved with these guys is that, very interestingly, these two codes, so on one hand you have sheaves on the Pn, and they're called multiplications. And on the other hand, you have the Betty tables. So these cones are very naively dual. You can take the standard infinite kind of the standard product that you can make, and these codes are dual. And now, these Ulrich bundles, they basically describe how the extremal rays in one code behave. There's a projective description, and they think they're either themselves extremal rays or something. So this is the motivation to say that. But basically, this was the motivation.
Yeah, thank you. Indeed, yeah.
What happens if you
Hmm?
it depends on the embedding.
Yeah.
What if you choose a different embedding, just take the derived there?
Yeah. Yeah.
Is it a new problem or
Yeah, it's then new problem becomes. Yeah. So I choose most natural embedding always, but
you take higher embedding?
yeah.
It's not known.
For this case, I think it's not known. Yeah. So yeah, even this rank 2, I think it's not known. Only Pn and some quadric, there are some results. But I think so. If one choose very non-trivial embedding, then this problem changes a lot. Yeah. So maybe I consider one more thing and finish. So yeah. Yeah. You mean that I take no, it's just not like that. So I can always you mean that I multiply my amplified bundle again and again. Even Pn case, I think for every embedding there are Ulrich bundle on so for every embedding. So what I mean is that this even though you multiply your vector bundle very high with very high, very ample line bundle, very ample line bundle, but still I think it's not trivial problem. Okay, I think I don't have time to discuss Fano problem. Maybe this is again suggested by Professor Bondar, but yeah, let me stop here. Thank you. Yeah.